They built an entire railroad, 50 miles of steel track, wooden bridges spanning mountain chasms, tunnels blasted through solid granite, locomotive shops, water towers, section houses for the workers. They surveyed the route, graded the roadbed, drove thousands of spikes into thousands of ties, and when the last tree fell and the last log rolled down the mountain, they ripped it all up. Every rail, every spike, every tie. They loaded it onto flat cars, hauled it over the mountains, and built the whole thing again somewhere else. This was the logging railroad. And for nearly 80 years, from the 1880s to the 1960s, these temporary rail lines carved their way through the greatest forests America had ever seen. They climbed grades that would have terrified a mainline engineer. They crossed valleys on trestles that swayed in the wind. They hauled loads so heavy that the rails would sink into the mud beneath them. And the men who built these railroads and ran these trains did work that defies modern imagination. They laid track through terrain so hostile that horses died of exhaustion just hauling supplies to the railhead. They ran locomotives up grades so steep that the engines would slip backward, wheels spinning on rails slicked with sap and morning dew. They rode log trains down mountain grades so steep and curves so sharp that derailments weren't a matter of if, but when. And then, when the timber was gone, they simply moved on. Like a surgeon removing stitches after the wound is healed, they pulled up the track and left nothing behind but the ghost of a grade cut into the mountainside. If you've ever driven through the mountains of the Pacific Northwest, or hiked through the forests of West Virginia, or wandered through the logged-over lands of the Upper Peninsula, you've walked on ground that these railroads shaped. The old grades are still there, overgrown with second-growth timber, but unmistakable to anyone who knows what to look for. A suspiciously level path through steep terrain, a series of rotten wooden stumps that once supported a trestle, a rusted spike half buried in the duff. These are the monuments to an industry that moved mountains, devoured forests, and then vanished so completely that most Americans have never heard of it. This is the story of the temporary railroads, and the men who built them to cut one forest at a time. To understand why anyone would build a railroad just to tear it up 5 years later, you need to understand what timber was worth in 1890. We're not talking about the lumber you buy at a hardware store today, kiln-dried and stamped with a grade. We're talking about old-growth timber, trees that had been growing since before Columbus landed, trees so massive that a single trunk could fill an entire railroad car. A mature Douglas fir in the Pacific Northwest could reach 300 feet tall and 12 feet in diameter. A single tree like that might yield 20,000 board feet of lumber. At 1900 prices, that single tree was worth somewhere between $400 and $600. Adjust that for inflation, and you're looking at $15,000 to $20,000 per tree in today's money. Now imagine a forest with 10,000 of those trees, stretching for miles across mountainous terrain with no roads. That forest was worth millions of dollars. The problem was getting it out. In the early days of logging, before the railroads came, timber operations were limited to waterways. You cut trees near rivers and streams, floated the logs downstream to a mill, and the geography dictated everything. If a forest wasn't near navigable water, it might as well not exist. Some operations used ox teams to drag logs overland. But oxen move slowly and eat constantly, and you can only haul logs so far before the cost of the animals and their feed exceeds the value of the timber. The railroads changed everything. A locomotive could haul 100 tons of logs at 15 miles an hour over terrain that would have killed an ox team. A railroad could reach forests that no river touched. And here's the crucial calculation that made the logging railroad possible. The timber in a single large forest could be worth $5 million, $10 million, sometimes $20 million. Building a railroad to reach that timber might cost $300,000. Operating it for 5 years might cost another $200,000. When you're looking at a potential profit of $4 or $5 million, spending $500,000 on temporary infrastructure isn't just reasonable. It's the only smart move. The lumber companies did the math. They looked at a mountain covered with Douglas fir and calculated the cost per board foot of every possible extraction method. Ox teams came in at $8 per thousand board feet, sometimes more in rough country. Flumes. Those wooden water channels that could float logs down from the heights cost about $4 per thousand board feet, but they only worked in terrain with the right grade and reliable water. A logging railroad, once built, could move lumber for about $2 per thousand board feet. At those numbers, the railroad paid for itself within the first year of operation. Everything after that was profit. And when the timber was gone, the rails and locomotives still had value. You pulled up the track, sold some of it as scrap, used the rest to build the next line, and the locomotive went right on working. The only thing you lost was the roadbed itself, the grading and the trestles. But even that could sometimes be converted into a public road or used for other purposes. This was industrial capitalism at its most ruthlessly efficient. The forests were temporary, the railroads were temporary. The towns that sprang up around the mills were temporary. Everything existed only to convert standing timber into cash, and when the conversion was complete, the entire operation would move on to the next forest, like a locust swarm, moving to the next field. Building these railroads required a particular kind of engineering madness. The timber was in the mountains, often at elevations between 3,000 and 7,000 feet. The mills were in the valleys, near navigable water for shipping. That meant the railroads had to climb and descend grades that mainline railroads wouldn't touch. A conventional railroad of the era considered a 2% grade to be steep. The Baltimore and Ohio's famous grade over the Alleghenies maxed out at about 2.5%, and that was considered a formidable obstacle that required helper locomotives and careful management. The logging railroads routinely built grades of 6, 8, even 12%. Some operations in particularly desperate terrain pushed grades to 14% or higher. To put that in perspective, a 12% grade means the track rises 12 feet for every 100 feet of horizontal distance. Stand at the bottom of such a grade and look up, and you're looking at something that feels more like climbing a steep hill than riding a railroad. The locomotives on these grades weren't really pulling their trains in any conventional sense. They were clawing their way up through sheer mechanical determination, wheels barely gripping rails that seemed to point toward the sky. The construction crews who built these grades worked with the same tools their counterparts used on the Transcontinental Railroad, but in terrain that was often far worse. They used picks and shovels and wheelbarrows. They used black powder and later dynamite to blast through rock. They built wooden trestles across ravines because there wasn't time or money to fill them with earth. The trestles were engineering marvels in their own right, but they were built from green timber, cut right there on the job site, and they were designed to last just long enough for the timber harvest to complete. I want you to picture what that construction looked like. You're standing on a mountainside in western Washington in 1905. The old-growth forest towers above you, trees so tall you can't see their tops without craning your neck until it aches. The undergrowth is thick and wet, a tangle of ferns and devil's club, and rotting logs from trees that fell centuries ago. But the air smells of cedar and decay and the sweat of working men. A crew of 30 men is cutting a railroad grade through this wilderness. They've been at it for 2 months and they've covered maybe 8 miles. At the front of the line, fallers are dropping the trees that stand in the railroad's path. Behind them, a crew with axes and crosscut saws is cutting those trees into manageable sections. Behind them, another crew is burning the brush and slash. Behind them, the grading crew is cutting into the mountainside, building a level shelf wide enough for a locomotive and cars. The work is unrelenting. A man swings a pickaxe 10 hours a day, 6 days a week, breaking through roots as thick as his arm and rocks that won't yield. His hands are blistered and calloused, his back is a knot of pain, and his boots are rotting from the constant wet. At night, he sleeps in a bunkhouse that smells of sweat and wool and kerosene. And in the morning, he gets up and does it all again. These construction crews move fast because they had to. Every day without a railroad was a day the timber wasn't generating revenue. The companies pushed the crews hard, and the crews responded with work rates that seem impossible today. Some operations laid a quarter mile of track per day through terrain that would give a modern construction crew nightmares. They did it with muscle and dynamite and an absolute refusal to acknowledge that what they were doing was insane. When they reached a ravine too deep to fill and too steep to go around, they built a trestle. These weren't the massive stone and steel structures you see on mainline railroads. These were wooden frameworks, built from trees cut within sight of the construction. And they went up so fast that the wood was still oozing sap when the first locomotive crossed. A trestle that would take a mainline railroad 6 months to build might go up in 3 weeks on a logging line. The trestles were terrifying to cross. The timbers creaked and groaned under the weight of a loaded train. The whole structure would sway in a strong wind, and some of them were built so high that a man standing in the middle could look down 200 feet to a creek running through the bottom of the ravine. The engineers who ran trains across these structures developed a peculiar kind of courage, the courage to trust that wood and gravity and speed would all balance out, that the trestle would hold just long enough for the train to get across. Some of them didn't hold. The Forest History Society has records of trestles collapsing under loaded trains, sending locomotives and log cars tumbling into chasms that became instant graveyards. The men killed in these accidents were often buried where they fell, the wreckage too heavy and the terrain too remote to allow for recovery. Their graves are somewhere in those mountains still, unmarked and forgotten. The curves on logging railroads were another engineering compromise that bordered on reckless. A mainline railroad might use a minimum curve radius of 500 feet, allowing passenger trains to maintain speed through turns. The logging railroads built curves with radii of 100 feet, sometimes even less. The locomotives that ran on these curves had to be designed specifically for them, with wheelbases short enough to negotiate the tight turns without derailing. Picture a fully loaded log train, carrying perhaps 200 tons of timber, navigating a curve so sharp that the rear of the train is still on the tangent track when the locomotive is already through the curve and heading up the next tangent. The cars aren't just rolling around this curve, they're being dragged around it, the outside wheels screaming against the railhead, the inside wheels sometimes lifting off the track entirely. The whole train is groaning and squealing, and any slight miscalculation in speed or braking could send the entire consist over the edge. These operational realities demanded specialized locomotives, machines designed from the ground up for conditions that no conventional railroad engine could survive. The geared locomotive became the defining technology of the logging railroad, and 3 designs dominated the industry: the Shea, the Climax, and the Heisler. Ephraim Shea was a Michigan logger who got tired of watching conventional locomotives fail on his logging lines. In the 1870s, he began tinkering with a design that would change everything. The conventional locomotive of that era used large driving wheels connected directly to the cylinders, a design that worked beautifully on level track, but that couldn't generate enough starting torque for heavy grades. Shea's solution was to gear down the power, trading speed for pulling force. The Shea locomotive looked like nothing else on rails. The boiler was offset to one side of the frame, balanced by a vertical steam engine mounted on the other side. This engine drove a horizontal crankshaft that ran the length of the locomotive, and that crankshaft connected through bevel gears to the axles of every wheel. The result was a locomotive, where every wheel was a driving wheel, all of them turning together with the irresistible force of a geared mechanism. A Shea couldn't run fast. Top speed was maybe 15 miles an hour, and most operations ran them much slower. But a Shea could climb grades that would have stopped a conventional locomotive dead. It could haul loads up 10% grades that would have sent a regular engine sliding backward, wheels spinning uselessly. And it could do all this on rough track, the kind of hastily laid, poorly maintained track that was the norm on logging railroads. The Climax locomotive took a different approach to the same problem. Where the Shea used a vertical engine driving through a longitudinal crankshaft, the Climax used angled cylinders driving a central gearbox that transmitted power to both trucks. The design was mechanically simpler than the Shea, with fewer moving parts and easier maintenance, but it sacrificed some of the Shea's legendary hill-climbing ability. The Heisler split the difference. It used a V-twin engine mounted in the center of the frame, driving a longitudinal shaft similar to the Shea's, but with a different gear arrangement. Heislers were popular in the Pennsylvania coal regions and in some western operations, prized for their smooth power delivery and their ability to run in either direction without the awkwardness of the offset Shea boiler. All three designs shared certain characteristics that made them perfect for logging work and useless for anything else. They were slow, they were mechanically complex, they required specialized maintenance that mainstream railroad shops couldn't provide, and they were loud, with a distinctive chuffing rhythm that sounded nothing like a conventional locomotive. Old-timers who worked around Shays described the sound as something like a mechanical heartbeat, a deep, rhythmic thudding that echoed off the mountain walls and announced the locomotive's presence long before it came into view. The men who ran these locomotives developed skills that transcended ordinary railroad engineering. They learned to feel the track through the throttle, on sensing the subtle changes in resistance that indicated bad rail, soft roadbed, or a curve tightening more than the survey markers suggested. They learned to work the brake valves with a delicacy that kept 200 tons of logs under control on grades where the slightest mistake meant a runaway. The log cars themselves were engineering adaptations born of necessity. Early operations used conventional flat cars, but these proved inadequate for the enormous logs coming out of old-growth forests. A single log might weigh 15 tons and span 40 feet in length. Standard railroad couplers couldn't handle the stress, and standard trucks couldn't support the weight concentrated over such a small area. The solution was the skeleton log car, sometimes called a disconnected truck car. Two sets of trucks, connected only by the logs themselves, could carry timber of almost any length. The logs were secured with heavy chains and binder dogs, steel devices that clamped into the wood and kept the load from shifting. A train of skeleton cars loaded with big timber looked like nothing else in railroading, the massive logs seeming to float above the rails on their minimal frameworks. Loading these cars was dangerous work in itself. The logs came down from the cutting areas on skid roads, dragged by teams of oxen or horses, or later by steam donkeys, the massive cable-driven winches that could drag a log 1,000 feet through the brush. When at the landing, where the skid road met the railroad, a gin pole or loader lifted each log onto the waiting cars. The men who worked these landings, hooking the choker cables and guiding the swinging logs, worked inches from instant death every minute of their shift. When the terrain was too steep, even for geared locomotives, the logging railroads turned to inclined planes. These were essentially mechanized steep grades, and were stationary steam engines at the top hauled cars up and down on steel cables. The principle was simple enough. A loaded car descending the incline provided the counterweight to pull an empty car up. The engine at the top controlled the speed, holding back the descending load and preventing a runaway. Some inclined planes dropped 1,000 feet in a quarter mile. Riding one was an experience that tested the courage of even veteran railroad men. You sat on a car held by nothing but a steel cable and the skill of the engineer at the top, looking down a grade so steep that the front of the car seemed to point at the ground. If the cable broke, if the brake failed, if anything went wrong, you had perhaps 3 seconds to jump before the car reached speeds that would guarantee your death. The switchback was another mountain-conquering technique borrowed from conventional railroading but pushed to extremes. Where a grade was too steep to climb directly, the railroad would build a series of zigzag sections, with the train reversing direction at each switchback point. The locomotive would pull the train up one leg, stop, and then push it backward up the next leg, then pull it forward again, working its way up the mountain like a snake climbing a staircase. On a typical logging railroad switchback, the entire operation might take half an hour to climb a grade that a helicopter could cover in 2 minutes. The brakemen would scramble off at each switchback point to throw the switches, then scramble back on as the train started its next leg. The locomotive would be running backward half the time, the engineer craning his neck to see past the boiler, trying to judge distances and speeds in reverse. One missed switch, one moment of inattention, and the whole train could plunge off the side of the mountain. Runaway trains were the nightmare that haunted every logging railroad operation. On a conventional railroad, a runaway is a rare catastrophe. On a logging railroad, it was a constant threat, always waiting for a moment of inattention or a mechanical failure. The loaded trains descended grades that would have been unthinkable on any main line, sometimes dropping 2,000 feet of elevation in just a few miles. The locomotives acted as brakes, their geared mechanisms providing engine braking that slowed the train's descent. But if the engine got overwhelmed, if a coupling broke, if the brake rigging failed, the laws of physics took over. A runaway log train was an apocalypse on wheels. 200 tons of timber accelerating down a mountain grade, the cars swaying and rocking on curves never designed for such speeds. The rails spreading under forces they were never built to withstand. The crew might jump for their lives if they had time. Often they didn't. The train would leave the rails on a curve, or a trestle would collapse under the impact loading, or the whole thing would just come apart, logs scattering across the mountainside like giant matchsticks. The death toll on logging railroads never made the newspapers the way mainline disasters did, but it was staggering. Logging railroad work was arguably the most dangerous industrial job in America during its era. The men faced not just the mechanical dangers of railroading, but all the hazards of logging itself: falling trees, rolling logs, snapped cables, and equipment failures killed men with grinding regularity. I've read the accident reports from some of these operations, and they make for grim reading. A brakeman crushed between cars when a coupling failed. A fireman scalded to death when a boiler let go on a steep grade. An entire crew killed when a trestle collapsed under their locomotive. A young man, 19 years old, killed on his third day of work when a log rolled off a car and caught him against a rock. These weren't names in a newspaper. They were men with families, with dreams, with whole lives ahead of them that ended in a moment of industrial violence. The companies recorded their deaths in ledger books and moved on, because the timber wasn't going to cut itself, and the trains weren't going to run themselves, and if you stopped to mourn every man who died, you'd never get any work done. The operations themselves ran on a schedule dictated by weather and season. In the Pacific Northwest, the rainy season turned the dirt roads into impassable mud, but the railroad tracks kept working. Winter brought snow that could bury the lines for weeks, requiring crews to dig out cuts and clear avalanche debris before operations could resume. Summer brought fire danger, and the locomotives themselves were a constant source of sparks that could ignite the slash and debris left behind by logging. The regional differences in logging railroad operations reflected the different forests they harvested. In the Pacific Northwest, the Douglas fir and western red cedar grew to staggering dimensions, and the railroads had to be built to handle individual logs that weighed more than a loaded railroad car would carry in any other industry. The West Side Lumber Company in California operated one of the most spectacular of these operations, with lines climbing into the Sierra Nevada to reach groves of sugar pine and ponderosa that had been growing since the time of the Caesars. In the Appalachians, the timber was smaller, but the terrain was often worse. The Western Maryland Railway's Potomac and Piedmont Division pushed into the mountains of West Virginia, where the narrow valleys and steep ridges forced the construction of switchbacks that seemed to defy geometry. The Greenbrier, Cheat, and Elk Railroad, despite its impressive name, was really just a logging operation with delusions of grandeur, threading its way up hollows so narrow that the locomotives could barely fit between the rock walls. The Great Lakes region had its own character. The white pine forests of Michigan, Wisconsin, and Minnesota were legendary for their extent and the quality of their timber, but the flat terrain and frozen winters created different challenges. Here, the logging railroads could often be built more cheaply and quickly than in the mountains, but they had to contend with spring breakup, when the frozen ground thawed and the roadbeds turned to mush. Some operations used ice roads in winter, building temporary tracks on frozen swamps that would be lakes by summer. The logging camps that supported these railroads were rough places. A typical camp housed 50 to 200 men in bunkhouses that smelled of sweat and tobacco and drying wool. The bunks were built in tiers, 3 high, and you slept on a mattress stuffed with straw or fir boughs under blankets that were washed maybe twice a season. The dining hall served enormous meals, 4,000 or 5,000 calories a day, because the work burned everything you could eat and then some. There was no privacy in these camps, no quiet, no comfort. The men came in from the woods exhausted, ate in silence, and fell into their bunks to sleep the sleep of physical depletion. On Sundays, if the weather was good, some of them might walk down to the nearest town for whatever entertainment was available, which usually meant drinking and occasionally fighting. Then they walked back, sobered up, and started the week again. The camp followed the railroad, and the railroad followed the timber. When the trees within reach of the current line were cut, the camp would pack up and move. The bunkhouses came apart into sections that could be loaded onto flat cars. The dining hall was built the same way. The entire infrastructure of human habitation could be disassembled, transported 10 miles up the line, and reassembled in a day. The men would go to sleep in one location and wake up in another, the same bunkhouse in a different clearing, like surrounded by a different section of forest that would look exactly the same until it too was cut. Some of the biggest forest fires in American history were started by logging railroad locomotives. The Great Fires of 1910 in Idaho and Montana burned 3 million acres and killed 85 people, many of them firefighters. The railroads were blamed for starting some of those fires, their spark-throwing smokestacks igniting tinder dry slash that hadn't been cleaned up properly. The lumber companies responded by installing spark arresters on their locomotives and clearing fire breaks along the railroad grades, but the fundamental problem remained. You couldn't run a steam locomotive through a dry forest without creating fire risk. It was a bargain the companies made with the devil, trading the possibility of catastrophic fire for the certainty of profitable timber extraction. As the years passed and the virgin forests fell, the logging railroads had to reach farther and climb higher to find merchantable timber. Operations that started in the foothills pushed into the high mountains. Lines that had been 5 miles long became 20 miles long, then 50. The infrastructure grew more elaborate, with permanent locomotive shops and car repair facilities, with telegraph lines strung along the right-of-way, with small towns growing up around the mill sites. But the fundamental economics never changed. The railroad existed to extract timber. When the timber was gone, the railroad had no purpose. Some operations tried to convert their lines to common carrier service, hauling freight and passengers for the communities that had grown up along the route. A few succeeded. The Simpson Logging Company's railroad in Washington eventually became part of the Milwaukee Road's Pacific extension. But most logging railroads simply died when the timber died. Their rails pulled up, their locomotives sold off, their rights-of-way abandoned to the slowly returning forest. The transition happened faster than anyone expected. In the 1930s, the logging railroads were still building new lines, still expanding into the last great forests of the Pacific Northwest and the Appalachians. But the trucks were coming. The internal combustion engine had been improving steadily for decades, and by the late 1930s, trucks were becoming capable enough to haul logs over mountain roads. They couldn't match the railroad's ton-mile efficiency, but they had advantages the railroad couldn't match. A truck could go anywhere a road could be built, and a road could be built faster and cheaper than a railroad. A truck could work in terrain too rugged for even the most aggressive logging railroad. And when the timber was gone, a truck could just drive away, leaving behind nothing but tire ruts that would heal within a few seasons. World War II accelerated the transition. The demand for trucks during the war drove improvements in power and reliability that made post-war vehicles far more capable than their predecessors. Army surplus trucks flooded the civilian market after 1945, giving small logging operators access to equipment they never could have afforded new. And the labor market had changed. The men coming home from the war had seen mechanized warfare up close, and they were comfortable with engines and transmissions and hydraulics in ways their fathers hadn't been. The logging railroads began to die. One by one, the operation shut down their rail lines and converted to truck hauling. The small operations went first, unable to afford the maintenance costs of specialized railroad equipment when trucks offered a cheaper alternative. The big operations held on longer, but even they eventually calculated that trucks made more sense. The Weyerhaeuser Timber Company, one of the giants of the Pacific Northwest timber industry, operated logging railroads into the 1950s with lines that stretched for dozens of miles into the Cascades and the Coast Range. Their operations were sophisticated by logging railroad standards, with well-maintained track, modern locomotives, and safety practices that were actually enforced. But even Weyerhaeuser saw the writing on the wall. The company began converting to truck logging in the late 1940s, and by 1960, their railroad operations were a fraction of what they had been. The Rayonier Corporation in Washington held on even longer, running geared locomotives into the mid-1960s. Their lines in the Olympic Peninsula served some of the last large stands of old-growth timber on private land, and the remoteness of the terrain and the size of the logs made railroad logging still competitive. But the old shays were wearing out. The track needed constant maintenance, and the labor force was aging. The men who knew how to run geared locomotives and maintain logging railroad track were retiring and dying, and there was no new generation coming up behind them. The last major logging railroad in the United States, operated by the Georgia Pacific Corporation in Northern California, didn't shut down until 1969. This was the California Western Railroad, originally built as a logging line, but later converted to common carrier service. When Georgia Pacific finally pulled the plug, it was the end of an era that had lasted nearly a century. Some of the locomotives survived. Museums and tourist operations bought them, sometimes for pennies on the dollar, and put them back to work carrying passengers instead of logs. The Roaring Camp and Big Trees Railroad in California runs restored shays through second-growth redwoods, giving tourists a glimpse of what the logging railroads might have been like. The Cass Scenic Railroad in West Virginia operates shays and Heislers on some of the original logging grades, climbing into the mountains where the timber was cut more than a century ago. But these preserved operations, as valuable as they are for keeping the history alive, can't really capture what it was like to work on a logging railroad in its prime. The tourists ride in comfortable cars on well-maintained track, with modern safety equipment and emergency services a radio call away. They don't smell the steam and the sap and the sweat. They don't feel the bone-deep exhaustion of a 10-hour shift in the cab of a locomotive. They don't understand in their bodies what it meant to bet your life every day on the skill of your hands and the soundness of equipment that was built to be temporary. By then, the era had already passed into legend. The old-timers who had worked the railroads were dying off, taking their knowledge and their stories with them. The locomotives had been scrapped or sold to museums or tourist operations. The track had been pulled up and the grades had been abandoned to the encroaching brush. But the marks on the land remain. If you know where to look, you can still trace the roots of these vanished railroads. The old grades cut through second-growth forest, suspiciously level paths that switch back up mountainsides where no road would ever go. The rotting stumps of trestle bents march across meadows that were once ravines filled with timber framework. Rusted spikes turn up in the soil, and occasionally a hiker will find something larger. An old railcar wheel, a section of rail, a piece of locomotive mechanism that somehow escaped the salvage crews. These are the relics of an industry that transformed the American landscape more thoroughly than almost any other human activity. The logging railroads didn't just cut trees. They opened up country that had been wilderness since the Ice Age, country that had never felt the footprint of industrial civilization. They built the infrastructure of extraction, the template that would later be followed by mining operations and oil companies and all the other industries that reach into remote places to pull out wealth. And they did it with a workforce of men who never got rich from the profits they generated. The loggers and the railroaders were paid by the day or by the piece, and when the timber was gone and the railroad shut down, they moved on to the next operation, carrying nothing but their skills and their scars. The wealth they created went to the timber barons and the company's stockholders, men who never swung an axe or crawled under a locomotive to grease a bearing. This is the part of the story that never makes it into the nostalgic accounts of logging railroad history. We romanticize the machinery, the locomotives and the trestles and the daring engineers, but we forget that this machinery served an economic system designed to maximize the extraction of profit from both the land and the men who worked it. The logging railroads were marvels of engineering improvisation, but they were also tools of a capitalism that treated forests as resources to be liquidated and workers as costs to be minimized. I don't say this to condemn the men who built and ran these railroads. They were doing the work that was available in the way the economy of their time demanded. Many of them took genuine pride in their skills and their accomplishments, and that pride was justified. Building a railroad through the kind of terrain these men confronted required intelligence, courage, and physical endurance that would humble anyone who has never done that kind of work. But I think we owe them the honesty of acknowledging what the system cost them. The broken bodies and the early deaths, the families left behind when the operation moved on, the communities that flourished for a decade and then vanished entirely, leaving nothing but a name on an old map and some foundations in the brush. The logging railroads are gone now, as completely as the old-growth forests they were built to harvest. A few tourist operations run restored equipment on preserved sections of track, giving visitors a taste of what it might have been like. Museums display the locomotives and the equipment, cleaned up and painted and accompanied by plaques that tell a sanitized version of the story. But the real story is written in the landscape itself, in the cutover hills that have regrown into forests that will never match what came before, in the creeks that run warmer and carry more silt than they did before the logging, in the old grades that trace the roots of vanished railroads, monuments to an era when men built entire transportation systems just to cut one forest, then tore them down and moved on to cut the next. If you ever walk one of those old grades, take a moment to consider what happened there. The men who surveyed the route and chose the grades. The crews who graded the roadbed and laid the track. The engineers who nursed their Shea locomotives up grades that should have been impossible. The brakemen who rode the log trains down, fighting to keep 200 tons of timber under control on curves designed by madmen. They're all gone now, those men. The last ones died decades ago. But the work they did shaped the world you live in. The lumber from those forests built the cities of the American West. The methods they pioneered influenced railroad engineering worldwide. And the pattern they established of building temporary infrastructure to extract natural resources became the model for industries that continue to operate today. We owe them something for that. Not uncritical admiration, but honest acknowledgement of what they accomplished and what it cost them. The logging railroads were extraordinary. The men who built and ran them were extraordinary. And the story of what happened on those mountain grades deserves to be remembered, not as nostalgia, but as history with all the complexity and moral ambiguity that history demands. The next time you're in the mountains, in the Pacific Northwest or the Appalachians or any of the other places where the logging railroads once ran, look for the signs. The level grade through steep terrain, the rotted stumps of trestle bents, the rusted spike in the trail. These are the monuments to an industry that moved mountains, killed forests, and then vanished like smoke. And somewhere in those mountains, in unmarked graves, lie the men who made it possible. They deserve to be remembered, all of them. If this story resonated with you, hit subscribe. Every week, I explore the forgotten history of American industry, the men who built it, and the true cost of progress. The next video is on screen now. I'll see you there.